Hey guys, welcome to this tutorial. Today I'm going to be teaching you how to integrate a basic physics system in Unity Dots using the new physics engine. And so it should look something along the lines of this. So you can see, you can move forward, backwards, all sorts of things like that, and then you can jump. Alright, let's go ahead and get started. Alright, here I am in the Unity editor, creating a new project. We're going to go ahead and say something like Unity Dots and Physics example. Okay, and then we go ahead and go in. Alright, now we're going to go ahead and download the correct packages for this. So we're going to go ahead and click on the show preview packages, grab entities. And once you download that, then you can go for the hybrid renderer. After that, you want to make sure you have all the physics stuff you need. I want to grab both of these. You don't have to, you could just grab the Unity Physics, but I'm going to grab both the Unity and Havoc Physics. And then make sure you have jobs and you have the burst compiler. And then once you have all of that, we're ready to go ahead and start. So let's go ahead and create a 3D object in the scene. Alright, once you create your plane, you're going to go ahead and create first a material. This is optional, but I like to have materials on my stuff. So we're going to name it ground, make it green because I like grass. So let's go ahead and make this a nice grassy color. And then just drag it on top. And now you have yourself a grassy plane. And I'm going to go ahead for this example, just do this so that we have some place to walk on. Make sure that your position is all, all this. And then what we're going to go ahead and do now is we're going to add the necessary components onto this in order to make it an entity that uses physics. So first we're going to go ahead and get rid of the mesh collider as it's not compatible with this new Unity Physics. Then we're going to go ahead and type in physics, and all you need is a physics shape. I would change this to something a little bigger. I'll explain why in a little while. And then once you do that, it should be ready for converting into an entity. And then you go ahead and you can run it. Now as you can see, it's in the scene. You don't really have to worry about anything. If we go to analysis, we go to entity debugger, you can see that the plane is now an entity. And so next thing we're going to do is we're going to create a cylinder or anything that you're going to represent as the player. And we're going to go ahead and delete this from him. And then we're going to add that convert to entity, as we're going to need it anyways. And then physics, we want to give it a physics shape. Make sure that it looks okay in here, which looks fine to me, except I want to change this to a cylinder. And once this looks all good, we're going to go ahead and also add physics body. Everything looks good here, but for this part I want to turn the friction to 0 personally, just based off of what my needs are, so that it walks smoothly on the ground. I'm also going to do the same thing for here real quick. and then we see all this, so it looks good. And then we're going to go ahead and add another component called physics step. And this is where if you wanted to make new physics, you would just, or if you wanted to use the Havoc physics, you would just click on that. Right now it's kind of in beta, but for Unity Free and Unity Plus, it's going to be for free, and for Unity Pro, you have to buy the license for it. So just keep that in mind. That's around sometime in January. And then the last thing I'm going to add is the Havoc's physics configuration. Just leave it on there just in case. And then we're going to go ahead and make that into a prefab. Yeah, just make sure everything's on here. Okay, and then we're going to delete that. And now what we're going to go ahead and do is start going into the code. So we're going to create a C# script, and we're going to go ahead and name it entity spawn. Go ahead and go inside, and we are going to delete everything here besides start. And then first thing we want to do is create a serialized field, and serialized field is pretty much similar to what would happen if you did a public variable, but it shows up in the editor, which I'll show you in a second, and you don't have to necessarily make your object public in order to get that reference in the editor. So we're going to say that's the prefab, and now we're going to go ahead and put this onto an empty game object. As you can see, now you have the prefab thanks to the serialized field, and then we just drop that in there, and now we're done. And then we're going to create an entity, just called, which you'll also need to use the using Unity.Entities. So you have entity. And then lastly, we're going to go ahead and put the entity manager. Right here. And then first thing, we're going to define what an entity manager is. Equals world.active.entity-manager. And then we're going to go ahead and create our source entity. Equals object conversion utility dot convert game object hierarchy. And then we want the root, which is going to be our prefab. It's going to create a copy, and we need the world.active settings. Alright, and then we're going to create what's called a blob asset reference, and it's going to be type collider, which you will need to do a couple things here. You're going to use using collider equals physics dot Unity.Physics.collider, and then you're going to still want to use Unity.Physics. Okay, and now we're going to name this as source collider is equal to em.getComponent data physics collider, and then we're going to pass the source entity so that we can get a what's called a blob asset reference of the source entity, and that's going to, and we want the value of this. And so now we're going to have all the information we need about our physics collider in this variable, so that when we create a new physics collider, which I'll show you right now, it'll have everything that we need already defined in that variable. So if we do for int I equals 0, I is less than 1, and this part right here where it says I is less than 1, this is how many entities you want to spawn. We're only going to spawn one, the player, so you don't necessarily have to do a for loop, but it's good practice. So we're going to go ahead and instantiate a new entity, which is going to be entity equals entity managed dot instantiate. Alright, and then once we have that, then we can pass in our source entity, which will create a new entity that we can sort of mess around with. And then we're going to say entity manager dot set component data entity new transform, and we're going to go ahead and create a new transform, and we're going to set that as the component data for the transform. Value is going to be equal to a new float3, and this is going to be its initial transform. So we're just going to put it up in the air just as to show what the physics engine is doing. And in order to access the float3, we're going to want to using Unity.Mathematics. And then to use transform, we're going to want to get Unity.Transforms. Oh, and we don't want transform, we want translate. There we go. Or translation, sorry. Okay, so now that we have that, then we want to create a component, another component, or we want to set a new component entity, and then we want to pass in our new component that we want to set that entity as, which is going to be new physics collider, and the value is going to be equal to the source collider. And if you're not sure what these give you or what the values you're supposed to pass in are, what you can do is you can click on go to definition, and it will show you right here what we want. So for this, the struct wants a value of blob asset reference collider, which is what this is, and so we pass in the right value. We're good to go. You can see the same thing from translation. If you go to its definition, it holds a float3 value, and so that's probably the easiest way you're going to figure out what values you need to put in for Unity components. You could also go to Unity documentations for these specific things, but it's going to be kind of hard to do that, so I'd recommend just using the definitions. Next, we're going to create a new variable, and I'm going to name it data, and we're going to set that equal to entity manager dot get component data. And what we're going to go ahead and do is get the physics mass, and we're going to pass in the entity that we want the component data of physics mass from, and that will give us physics mass. And then what we're going to go ahead and do is I want to actually change a value that is inside of this data. So we're going to say data dot inverse inertia is equal to new float 3.0. And what this does is for our sort of testing, it's going to go ahead and make sure that the object cannot rotate. That the rotation calculations won't happen for our object, which means that if we're standing off a cliff, for instance, we're not going to just tilt into a 90-degree angle and sort of do that stuff, which a lot of games like to do. So this is what I want. So I'm going to go ahead and add that, but if you want your character to sort of move around like that, that's completely up to you. And then now we're going to have to do entity manager dot set component data entity, and then we're going to pass in our data variable. And this is also an example of how you would change specific values inside of an entity. Like if we check the definition of this, we see that it holds quite a few of them. It holds transform, it holds inverse mass, it holds inverse inertia, angular expansion, factor. I'm pretty sure these are also values. And so if I were just to do new physics collider, I would lose that other stuff and it wouldn't work. So I'd rather, to be able to change one of these, grab the component data and then just change that and then pass it back, which is going to be the easiest way of doing that. And then once we go ahead and do that, we're pretty much done here. We can go ahead and save this and then go back to our game. And what we're going to go ahead and do is we're going to play it just to see how it looks like. As you can see, it falls down and it collides, which is great. That's what we wanted it to do. So now that we're done with that, we're going to go ahead and create a new system. So we're going to go back to Unity and we're going to create a C# script. And we're going to name it just test job for now, since this is just for testing purposes. We go in and now we have to, instead of getting mono behavior, we want to go ahead and get job component system. And there's two types of variables that you'll normally want when you're creating a job. You could either get, or to create a system, you could either use job component system or you could use regular component system. And since we're going to create a job which is going to be multi-threaded, we're going to go ahead and use job component system. So we want to use Unity.jobs in order to gain this reference. Let's try using Unity.entities. I'm pretty sure that will work. Yes. Okay. And now this says that test job does not implement an inherited abstract member job component system on update. So let's go ahead and remove that, and then we can check the definition real quick of the job component system, and we see that it wants us to create this. So to do that, we're just gonna copy this, paste it, and we're gonna say protected job handle on updates, or we want to also override this protected override job handle on update. And then now we have that, and it's going to return, let's say for now it returns input dependencies just to get rid of that error, but we're going to go ahead and change that later. And then what we're going to want to do next is we're going to create a new job, which is going to be a struct new job, which is going to inherit I job for each, which then gives us the ability to pass in our queries, and the queries are going to be the components. And what this is going to do is it's going to check every entity for its components, and if the components have all the query requirements, it's going to grab that and it's going to create a reference for us. So let's say we want to grab physics velocity, and we want to also grab translation, which means that we're going to need using Unity.Physics, using Unity.Transforms. And then what we're going to go ahead and do now is we're going to implement what we need to do for this. It needs to implement a public void execute, and then we want to grab a reference for our physics velocity, which is going to be velocity, and then reference to our translation, and we're going to call that translation. And then that pretty much solves the issue. And then inside of here is going to be where all of our code runs. And so what we're going to need to do is we're going to have variables that we're going to pass into it from outside, because you can't for instance, you can't say, oh, I want input that get access inside this job. It won't work. So what we need to do is we need to create some variables. So we're going to say public float horizontal, public float vertical, public bool space, and then we want bool hit. I'm just doing all this sort of preemptively. And actually, we don't need this right now. I'm going to do the example in a minute. But anyways, now we have all this, we can go ahead and actually start to write what we need in our code. So we're going to create a new job. So variable job equals new move job, which is the struct. And now we need to pass information into it. So what we're going to go ahead and do is we're going to add that and then open it up so that we can start passing references into it. So horizontal is going to equal to input.getAxis horizontal, for instance. Okay, and then and we want this to be these to be commas. And then the next one is vertical equals input.getAxis vertical. Lastly, space is equal to input.getKey down key code dot space. And make sure to put a comma always at the end as well. And so now what will happen is it will pass all this. And then now the last thing we can do is we can finally change this to job.schedule. We have to pass, okay, this and the input dependencies. Okay, and that should work. And so now when this system runs, it will run this either every frame or 60 times a second, I'm not sure, but now that what allows us to do is we can use this exact update, and we're going to say velocity.linear is equal to new float 3. Oh, we need to also create using Unity.Mathematics new float 3, and we're gonna say just for the example, let's say our speed is 3, so we're gonna say 3 times for the x it's gonna be horizontal. For the y we're just gonna say velocity.linear.y, and then lastly the z-axis is gonna be 3 times vertical. And then we're going to go ahead and say if space, which is our boolean, we're going to say velocity.linear is equal to new float 3, velocity.linear.x 6, and velocity.linear.z. And then we're going to also put on this attribute for this first compile, which we'll need to use Unity.First. Okay? And then now if we go ahead and run our game, you'll then notice that we're able to move with the keyboard and we can jump. But the only issue now is, I can jump forever. Right? So that's not good. And so what we want to do now is we want to use the Raycast, which we're going to use the new Unity Raycast. And this is probably going to be the most difficult part because a lot of the errors that you get when you're working with this are very ambiguous, and it's very difficult to sort of know exactly what you're doing. But I'll go ahead and walk you through this. So you may not exactly understand everything, so just follow along as well as you can. So what we're first going to need to do is we need to have some reference to the cast array. So we're gonna start off by creating variable physics world equals world.active.get existing system unity.physics.systems.build physics world. Okay, and so that will give us the variable build physics world. And what we're going to go ahead and do now is we want to grab a few more variables here. So we want to grab public physics world, and then we also want to grab public collision filter. Okay, and this right here will give you the biggest pain if you forget to do this. First, we want to get Unity collections, and then we're going to have to set this as read only, because if you give it write permissions, even if you don't write to it, you're going to get errors, and it's not going to let you do anything. So make sure that the physics world is read only. Okay, and then next what we're going to go ahead and do is we're going to pass physics world equals physics world dot physics world, because this variable is not a physics world, it's a physics build physics world. Okay, and so we need this, and this represents the move jobs physics world, this represents our physics world, so it's not ambiguous. And now what we're going to go ahead and do is we want to create a filter equals new collision filter, and then we just open this up, and so we can type belongs to, which tells it what type of colliders it has on it, and we're just going to say all of them, which this is how you would say that. And then collides with is equal to uint, and we want to create, so this will get what this says is you're getting a uint, which will create a string of binary where it puts 1 at the 0 position. Okay, so we're going to go ahead and do that. And now all that's passed. And then one more thing before we can even get the Raycast to work is we're going to have to create a new dependencies, which is equal to job handle dot combine. We're going to combine the two dependencies that we have, input depths, and then we're going to combine the new one, which is going to be, it's going to be physics world dot final job handle. And then once you have that, you're going to create a variable handle, which is equal to job dot schedule this and the new dependencies, right? And then lastly, because the Raycast won't work very well without this, we're just going to say handle.complete, and then we can go ahead and pass this handle instead. And now that we have all that set up, it should work now. And then what we're going to go ahead and do is we're going to create a boolean, which does not need to be passed, called hit. We're just going to use it in our code, and we're going to create, let's go ahead and start at the top here. We're going to say variable, which is ray input, is equal to new raycast input. Now we have to define in this new raycast input dot start is going to be equal to translation dot value minus new float 3. And the reason why I subtract this is because we don't want this raycast to intersect with our character. I'm not sure with my new with some of the new changes I've made if this matters or not, but I'm going to say it does for the sake of this video. And then we're gonna say ray input.end is equal to translation.value minus 1.4 times new float 3010. Okay. And so that should hopefully check to see if you're on the ground. And we're going to say the ray inputs filter is equal to filter. And just so I kind of make sure that the people who haven't done this before understand, you can check the definition. You see collision filter, start and end. So you know exactly what you need to put into this in order to get things to work. So once you have that, you're gonna go ahead and now write to that hit variable, which is going to be hit equals ray, it's gonna be physics world dot collision world dot cast ray, and we're going to pass our ray input as the parameter. And I messed this up. Okay, there we go. Now that gives us a variable that we can use that's a boolean, as we've referenced up here. And so if we say if space and hit velocity.linear is equal to new float 3, which will be our space, right? So now that we're done with that, let's actually set up just a little bit, just so you understand why our collision filter is the way it is. So what we're going to go ahead and say is, let me look for it. So the collision filter here, we're going to create some new filters. We're going to say the ground, and that should be it for what we need. So that's going to be the ground, and we're going to say that this belongs only to the ground, and that should work. And then the player, I believe, should be good. And so now this should only collide with the plane. And so now that we have that, we're going to go ahead and test. Okay, and we see there's an issue here. Okay, let me just check real quick just to make sure everything's good. Okay, so we want we want this to not collide with the player, so we're going to create another one called player. Yep, and then we're going to go back to it. And collides with everything but, or does everything but, oh wait, I want this to be raycast. Okay, and then we're going to go ahead and change, we're going to make this player so that it belongs to the player. good. Should then allow this to hopefully work. Alright, there you go. And now it's working. So I believe if that works, then what we should be able to do is actually remove this. And we're going to retry the code. And it should hopefully work the way that we wanted it to. Yep. Okay, to go over what I sort of did right now, so now that I've tested it works, is in the physics shape you have a collision filter that belongs to and collides with. So right here, I'm saying that the player cannot collide with our raycast, which is raycast in the ground. You might want to say that ground raycast or something if you're going to have other raycasts, but the point is that this belongs to player, and then for the ground you can see that this belongs to ground and collides with everything, so that's good. And what it says in the code here is that this belongs to everything. You could say that it's a raycast, which I suppose we can. So if we say uint 1, and our raycast is on the 1 position, I believe. Let me check. Okay. Yeah, it's on category 1, so we're going to do that, and it collides only with the ground. And so if we play that, this should work perfectly. And there you have it. That should pretty much be it. Let me just go ahead and go back into the code. And just to let you know, you can't use debug log on the booleans if you are running burst compile. So let me just remove that, burst compile. And then now you have a completed setup. But I am going to show one more thing that you can do. Which is, I'm going to create a new C# script called empty tags. And we're just going to get rid of all of this, and we're going to create a public struct grounded, which is going to be from iComponent, or it's going to be, let me think real quick. So I think so we need using Unity entities. And then it should be iComponent data. Okay? And then this holds, we're going to say this holds nothing. So it's going to be our tag, right? And so now we can go into entity spawn. And we can say, we're going to say entity manager dot add component data. Entity. And we're going to add a type of grounded. And the reason why we're doing that is because when you call... Oh, whoops. Wait. Oh, sorry. Not add component data. We need add component. There we go. And so when we look at the definition of add component, which is right here, it wants a component type rather than just a component, so we have to do type of. And then now what we're going to do is we're going to go into test job, and the reason why we're doing this is because we want to add the attribute to our job called require component tag, and then we're going to pass in type of grounded. And what this does is it will slash every entity from the list besides the one that has the component tag grounded, and then it will check the query for that. So it just makes it a little bit faster. Plus also, if you have other objects that have physics, velocity, and translation, but you don't want this code to run on it, then you can add a tag to differentiate what this code is going to run on and what it isn't going to run on. So if we go ahead and I'll actually show our example real quick, which I believe, 1 second, is this? I have some errors. Okay. Where is this at? Entity spawn. Did I save? Okay, I don't think I saved. Anyways, so I'll show you how this works exactly. So we're gonna say that the player has a tag, so it works as fine. But what happens if the entity does not have the tag? The code doesn't run at all. As you can see, it's doing nothing. And so that's very useful when you need to differentiate where the code is running and where it isn't, because this code will run automatically on anything that has these. So this will conform it to only run if it has this tag. And that's pretty much all for the tutorial. Hope it helps. And if you guys want me to cover anything else, just let me know. Thanks. Bye.